All right, everyone, thank you for coming. And today we have a distinct honor of having Professor Peter Vickers from Durham University. I think Peter, we met about a couple of years ago at Goddard when you visited and gave similar presentation. And so this new work I thought was about to be interesting for everyone. And so Peter, whenever you are ready, please go ahead. And I'll mute myself and be off the screen. And I suggest to do the same for everyone except the speaker. Thank you.
Thank you. Thanks so much, Ravi. Thanks for having me. I've got fond memories of my visit to Goddard a few years ago. I think it was just before the pandemic hit. So it was a lovely visit. And in a sense, I've been working towards this paper ever since, and it's just been accepted in astrobiology a couple of weeks ago. So you won't see it online yet, but it'll be coming out shortly. But it's not just me. This is a team project, and it's part of a project that comes from. It's funded by the Leverhulme Trust, and it's called Eureka, and that stands for Exploring Uncertainty and Risk in Contemporary Astrobiology. So this is a 3-year project, and we're currently in the 2nd year of it, collaborating with the UK Centre for Astrobiology, and the co-I on the project is Sean McMahon, who you might know. Some of you might know the name. He's an astrobiologist through and through, I think you could say. Whereas I'm a philosopher of science who's come into the field just in the last 4 years or so. And this is the paper that my talk today is going to be based on, where it's a nice combination of philosophers and scientists. It's the most thoroughly, I think, we've ever sort of combined the two. Often in the past, we've been a bunch of philosophers with one token scientist, or vice versa. But this is a thorough integration of the two, which is nice. So although this isn't conceived as a techno-signature paper, I think it applies equally to techno-signatures. And you can think of Oumuamua as one example of a possible techno-signature, or a candidate, if you like. And you'll all be aware of papers such as this one, which are making the case. So there's a question that arises for any kind of phenomenon or signature. If somebody claims that could be extraterrestrial life, we want to be able to say how confident we are. Is it a little bit likely, or very likely, or somewhere in between? Can we put a number on it? Can we say that the rational credence in that claim should be 0.25 or something? These are the sort of questions we've been grappling with. So I'll come back to Oumuamua, but the case we've been thinking about quite a lot is the case where perhaps one day we'll have a signature which is an oxygen-methane disequilibrium discovered in an exoplanet atmosphere. So this is a possibility, and we consider this because we think that if this were discovered, there would be headlines around the world saying no known abiotic explanation. It's definitely a biosignature. At least some people would be saying that. Some scientists, I'm sure, not just journalists. And it may well be the case that currently we wouldn't have an abiotic explanation of this phenomenon, but we would have at hand a clear biotic explanation or candidate explanation. But there would still be this underlying question: just how confident are we that we've detected life? If we were to detect this, should we say it's certain? Well, definitely not. But it's somewhere, if you like, between uncertain and absolutely certain. you know, how should we actually express ourselves? Should we say it's very likely, or it's quite likely, or should we try and put a probability figure on it? Now, the problem that we bring to bear actually comes from the philosophy of science literature, and this idea called the problem of unconceived alternatives is at the heart of this influential book in philosophy of science circles called Exceeding Our Grasp: Science, History and the Problem of Unconceived Alternatives by Kyle Stanford. And this is a book that's had, I think, wide influence. And the idea of unconceived alternatives is one that, you know, is quite obvious in a way. You know, there in science throughout its history, there have always been unconceived alternatives that were later conceived. But it's what we do in our paper is we bring that to bear on examples of candidate biosignatures or technosignatures. And we use some examples from history to sort of bring this to life. It's an interesting example here from this Nutman et al. Paper from 2016. And a suggestion here that there's this strong evidence of the emergence of life 3.7 billion years ago. And they use this word shown, and they also appeal to the fact that there is no known abiotic explanation of this specific phenomena. At least to their knowledge, there's no known abiotic explanation, but they offer a biotic explanation. However, 2 years later, we have this paper from Allwood et al., where they say, look, here we report new research that shows non-biological post-depositional origin for the structures in question. So within 2 years, there was a non-biological or abiotic explanation of the same phenomena. And although the debate is ongoing, you know, the emergence of a previously unconceived alternative abiotic explanation is obviously changes our assessment of the original claim quite considerably. And what we say in the paper is that this has been quite common throughout the history of astrobiology. Even oxygen accumulation in the atmosphere of an exoplanet is something that at one time we wouldn't have had a good abiotic explanation for. Nowadays, we do have more than one good abiotic explanation, which means that if we discovered oxygen in the atmosphere of an exoplanet now, we'd be far less excited by that. You know, there are plenty of ways that could happen without life being present. The point that we want to make, first and foremost, is that these examples should mean that even if we found an oxygen-methane disequilibrium, we might learn from these past examples and say, look, we don't have a good way of explaining this abiotically now, but history shows that there's every chance that we will have in, you know, 5, 10, or 50 years' time. But I think there's a tendency to make this jump. We can't currently conceive of any plausible abiotic mechanism for such a disequilibrium. So it's highly likely that disequilibrium has a biotic cause. It's this kind of inference that we're worried about in this paper, that we think that does get made sometimes. And I think there's evidence of this in the literature as well. Actually, there's this specific paper that came out in 2018 on disequilibrium biosignatures. And here we find this statement: the methane flux required to sustain observed quantities of methane in modern Earth's oxidizing atmosphere is greater than what abiotic processes could plausibly provide, and thus biological methane leakage must be invoked to explain the persistent disequilibrium. So we do have this disequilibrium on the Earth, and it's explained biologically. But the idea, if we were to discover such a signature in an exoplanet, I think there would still be this tendency for people to say, well, for that disequilibrium to persist, it must be biological methane leakage. And there would be the tendency to say that on the grounds that we can't think of a way in which it could be abiotic. But that's the worry from unconceived alternatives. Perhaps there is a way, we just haven't conceived of it yet. So one of our starting points is this paper that you may know of, that brings in the COLD scale, the confidence of life detection scale. And the paper is Call for a Framework for Reporting Evidence for Life Beyond Earth. There's an underlying idea here that there's a certainty continuum from completely uncertain to absolutely confident, and that we ought, in principle, to be able to tell people, to be able to tell the world when we have a signature, how confident we are. Where are we on that scale, that continuum from being, if you like, unsure to being absolutely sure that it's extraterrestrial life is responsible. And this is the scale. So hopefully most of you have seen this and thought about it. The idea is that you know, right down at the bottom we're completely unsure, but if we get right up to the top of this scale, then we're certain or almost certain that we have actually discovered extraterrestrial life. Now, an interesting point for our purposes is level 4. All known non-biological sources of signal shown to be implausible in that environment. So, given what I've said so far, you can perhaps see how this is going to go. It's going to depend how thoroughly we've looked for non-biological sources. The fact that all known non-biological sources of the signal have been shown to be implausible needn't mean that there aren't some or even many non-biological explanations that we just haven't conceived of yet. So how significant is it that all known abiotic sources have been ruled out? So here's 2 scenarios to think about. One is where we've explored the possibility space for abiotic explanations thoroughly. So if the possibility space is represented by the blue circle here, then we can imagine a scenario where we've explored the space very thoroughly. Not entirely, you know, perhaps it's not possible to explore a space of this kind entirely, but we've explored it thoroughly. I mean, there are scenarios where we think we've explored a space entirely. You know, if you think about the periodic table of elements, nobody really thinks that there's room for another element, you know, that we need to keep exploring the possibility space. No, we have theoretical reasons there for thinking we've exhausted the possibility space of elements. But there are many other scenarios where we don't have the same kind of underlying theoretical reason to think that we've thoroughly or completely explored a possibility space. And just to remind you here, I mean, think specifically, if you like, of the methane oxygen disequilibrium biosignature. So the scenario we're thinking about here is where we've so thoroughly explored possible abiotic sources of such a disequilibrium that we're almost ready to say that if we find such a disequilibrium, it has to be life. The other extreme is that we've only just started exploring the space. And if that's true, then the fact that everything we've looked at so far suggests that such a disequilibrium is caused by life doesn't mean very much at all. I mean, there's so much of the possibility space left. It could easily be the case that there's one or more different abiotic explanations for that phenomenon. This sort of idea is taken up in this nice paper by my co-I, Sean McMahon, and Julie Cosmidis, false biosignatures on Mars anticipating ambiguity. Part of the reason they're anticipating ambiguity is because there'll be signatures where, although it could be life, we just don't really know, because it's possible, even if we can't think of an explanation, an abiotic explanation, there could easily be one we just haven't thought of yet. So an important passage here is this. This area of inquiry has received rather scant and unsystematic attention from astrobiologists, who have tended to focus their published work on expanding our knowledge of life's signatures rather than its abiotic mimics. So what they're saying is that to be sure that something is an actual biosignature, that the biotic explanation is the correct one, you have to have done thorough research into abiotic mimics. So abiotic processes, non-biological processes that produce phenomena which look like they might have been produced by life. They go on, given the haphazard and unsystematic way in which varieties of false biosignature have so far been identified, we can only assume that many others remain undiscovered. So false biosignature being a case where something looks like a biosignature because we can easily think of a way that that phenomenon could have come about because of biological activity. But it turns out later on that a better explanation, or an equally good explanation, exists where that phenomenon came about because of non-biological activity. There are lots of interesting examples trying to explore a possibility space. One is the limits for life under multiple extremes. And there's this paper from 2013, which looks at the limits for life under multiple extremes. And one of the figures is this. But what's important here is that we haven't explored the possibility space that thoroughly. So this figure doesn't actually give you the limits for life under multiple extremes. It just tells you what we've explored so far. And they're two very different things. So when we've explored the space of possibilities for life under multiple extremes more thoroughly, this graph will look very different. So this represents really the state of knowledge in the field. It doesn't represent the possibilities for life under multiple extremes. So this is one illustration. What's interesting here is that at least the variables are nicely defined. You know, we want to look at different values for pressure, pH, temperature, and maybe some other options as well. When we've thoroughly explored this space, I mean, you can actually conceptualize this as a space, which is nice. We'll know when that is, really. Whereas other spaces are far less tangible. So think of the space of possibilities for abiotic production of an oxygen-methane disequilibrium. It's hard to sort of think what that space even looks like. One thing we engage with in the paper is Bayes' theorem, because there have been several papers suggesting that Bayes' theorem has to be the right way to make rigorous uncertainty judgments. But we don't find Bayes' theorem helpful on this particular issue. So in order to use Bayes' theorem, you have to be able to fill in this term, the probability of E given not L. So here L stands for life, and E just stands for some phenomenon that has perhaps been put forward as a potential biosignature or technosignature. And we have to put a probability, to use Bayes' theorem, we have to put a probability value in for this. What's the probability of that phenomenon occurring if it's not life? And again, the only way you can actually do that is if you've thoroughly explored the possibility of abiotic sources for that particular phenomenon. If we haven't explored the possibility space very much, we can't responsibly input a value here. That's what we argue in the paper. And what we should say is we just don't know. We haven't done the research. If this value remains very uncertain, then Bayes' theorem doesn't help us to reach a value for what we really want, the probability of life given the evidence. And we suggest a conflict between what would happen if we discovered an oxygen-methane disequilibrium, or be a lot of excitement that we might just have found life, and what a sober assessment of the relevant uncertainties would suggest. So this is a depressing paper, so I'm sorry about that, but we're trying to rein in the excitement here. So this is the move we worry about. We can't currently conceive of any plausible abiotic mechanism for X, so it's highly likely X has a biotic cause. When it comes to the cold scale, if we reach level 4, where the maximum is 7, it seems like it's time to start getting excited. Perhaps we're halfway up now. It seems like this scale is being put forward to represent, if you like, the certainty continuum, where the bottom is totally uncertain and the top is totally certain. 4 then should mean that we're starting to become confident that that we might have found life. That's what it would seem to represent. However, reaching level 4 is hugely significant if we've thoroughly explored the possibility space. It could even be the case that we know that we've found life, because if we've thoroughly explored the possibility space, then the fact that all known non-biological sources of the signal are shown to be implausible in that environment would also entail that all non-biological sources are shown to be implausible in that environment. That's the extreme case where we've explored the possibility space 100%. But if we've only just started exploring the possibility space, and the fact that all known non-biological sources of the signal are shown to be implausible in that environment doesn't help us at all. We're still completely uncertain. So level 4 is consistent with high confidence and low confidence, depending on how thoroughly we've explored the possibility space of abiotic explanations of the phenomenon in question. So this level 4 means we're very confident if we've thoroughly explored the space, and not at all if we've just started. So this is why we're worried about this scale. The take-home message being that quantifying uncertainty and assessment of possible exoplanet biosignatures requires quantifying the extent to which we've explored the possibility space of abiotic mimics. An interesting example is the case of Oumuamua, and this new paper that came out just this month, where it's been suggested to me this is a strong move in the case towards fully natural explanation of Oumuamua, but it's putting forward, if you like, an unconceived alternative abiotic explanation for Oumuamua's acceleration, which initially it was claimed by some was most naturally explained in terms of a non-natural source, or a light sail or something like that. So this is another example where once you start exploring the space more thoroughly, it may well be the case that you find that abiotic explanation. So we want to do something positive in this paper and look at how we should express our degree of confidence in a given case. What kind of process could there be to express degree of confidence that we found life in a given case? Now, when we first started writing this paper, we thought we were going to directly respond to the cold framework, but in the process of writing the paper, this white paper came out that was based on the Standards of Evidence for Life Detection Community Workshop, which took place in July 2021. And there's this community report led by Vicky Meadows. And this is a thorough engagement already with that paper. And some of you may well be co-authors on this. So it was necessary then to sort of rewrite our paper a little bit to respond to both. So perhaps the most interesting thing about this this community report is that they reject linearity. So in the cold framework, the cold scale, we have this linearity, 1, 2, 3, 4, 5, 6, 7. And there's a suggestion in the community report that that's not going to represent scientific activity. They have a preference for iteration. So where iteration means, perhaps asking questions again after you've found out new information, you go back and ask questions more in a process of iteration rather than going through a series of steps towards a final point. So this was, if you like, an implicit criticism of the cold scale, not particularly explicit actually in the white paper, but my team saw it as an implicit criticism. So they specify 5 questions that have to be asked in such a case. Have you detected an authentic signal? Have you adequately identified the signal? Are there abiotic sources for your detection? Is it likely that life would produce this expression in this environment? And are there independent lines of evidence to support a biological or non-biological explanation? But they don't see this as a set of questions that you answer linearly. This is the way they see it. There's a level 1 where you're asking the first 2 questions, and there's iteration at that level. But there's also a level 2 where there's interpretation, and you're asking questions 3, 4, and 5, but there's iteration at that level as well. And in some cases, there may be even iteration between levels 1 and 2. And this seems to be put forward as an alternative to the cold scale. And here's what we say on that. So I'm just going to quote from our paper here. With the move from the cold scale to the n-fold nexus framework, we correct the presentation of scientific methodology at the expense of deprioritizing the goal to effectively communicate confidence of life detection. So it seems to us that the n-fold nexus framework, namely this framework on the right here, is more suited to scientific methodology, representing scientific methodology, but we're left without a way to read off from that how confident we should be that we've detected life. Whereas the original cold scale was supposed to give us a scale from 1 to 7 of how confident we should be that we've detected life. Now, so there's 2 different things here. How do you present ideal scientific methodology or good practice scientific methodology? And how do you communicate confidence of life detection? So we go on. It remains the case that confidence of life detection should be something one can, in principle, map onto a linear scale, ranging from no confidence at all to full confidence. So we totally agree that science is iterative and non-linear, but on the other hand, there is linearity in the concept of confidence. How confident are you that you've detected life, ranging from, on a scale from 1 to 10? How confident are you, where 10 is you're absolutely certain? I mean, there should be something that you can say about how confident you are. And the move to the n-fold nexus framework, although improving on the cold scale in some respects, does take away that initial goal. And our solution to this is to draw on the IPCC uncertainty framework. So there's this framework that actually gives us a confidence scale already, and it's based on considering the evidence, the type, amount, quality, and consistency of the evidence along the x-axis, and then the amount of agreement in the community about the case. So in the extreme case, there's loads of evidence and there's consensus in the community. In that case, your confidence is very high. And then you can have different alternatives here. And we argue in the paper that this is the best you're going to get in terms of a framework from which you can read off how confident we should be about a given detection scenario. So if you've read one of these IPCC reports, you'll see that they make lots of statements in them, and they use this framework to actually give sort of a qualitative judgment on how confident they are or how confident we should be. So this is just an example. The ocean has absorbed about 30% of the anthropogenic carbon dioxide, resulting in ocean acidification and changes to carbonate chemistry that are unprecedented for at least the last 65 million years. And then this high confidence statement at the end, which is a direct reference back to the framework, and it's to say that, you know, considering the evidence and the agreement in the community, we should say that we have high confidence in this statement. And this is the kind of thing that we argue could also be used in astrobiology. So here's what we say. If this uncertainty framework can be considered adequate for the IPCC reports over a period of more than 20 years, when the stakes are so high and clear communication with laypersons and policymakers couldn't be more important, then mightn't it also work adequately for astrobiologists eager to adopt an exactly similar continuum, but now for confidence of life detection? Over the past more than 20 years, including 4 IPCC reports, this framework has been heavily scrutinized. Whatever your view, in the face of extraordinary scrutiny and the highest possible stakes, this uncertainty assessment framework has stood the test of time. So here we're engaging with some of the discussion in that N-fold Nexus white paper about what would you want this kind of framework to do. You'd want to be able to read off fairly easily from it how confident we are, and to be able to communicate with journalists and the public. That's one of the goals behind this, not just to articulate for ourselves, you know, the expert community, how confident we should be, but to actually communicate more widely. This is seen as an important goal of a framework like this. And that's exactly the situation in the IPCC. Of course, it's not just about trying to work out how sure we are for our own sakes, but to communicate with the wider world. So there's a nice analogy there. So if you were to use this, how would you use it? You might have statements like this. Oumuamua has a natural origin and is not an alien artifact. Medium-high confidence. Some of you might think medium-high confidence is a bit low. And it should be very high confidence. But I mean, that paper that I mentioned earlier has only just been published this month. There hasn't been time for thorough scientific community scrutiny. You know, this is all very fresh, and you know, when the science is fresh, you need to sort of see how the community responds over a period of time, and that's how you're going to come up with a good sense of where our degree of confidence really lies. In the case of Oumuamua, you know, the evidence is still, I mean, it's not highly robust. You know, we don't have that much evidence, and the agreement is definitely not really high. There's so this is why I suggested this medium high confidence for this statement. But that's just my, I mean, this isn't how it would work in practice. There would be a committee that was tasked with working out how confident we should be based on the evidence and the agreement, as it's much like it's done in the IPCC reports. So just before I finish here, there are three positive proposals that really come out of this paper. The first is that the community could profit from adopting the time-tested IPCC uncertainty framework. I don't think the community needs to invent its own framework. One thing we discuss is whether the IPCC framework is too thin on details, but it's precisely when you try to add details in, as we saw with the cold scale, that you get all of this disagreement in the community, and it causes problems. And we argue that it's actually an advantage of the IPCC uncertainty framework that it is, it doesn't include details about, precisely which questions should be asked, or it doesn't say much about the evidence, except, that you should judge the amount of evidence, the quality of the evidence, and so on. The second thing we propose is, if we want to assess biosignature uncertainty more rigorously than is currently possible, we need much more data on the topic of abiotic mimics. So this is just that point about focusing on abiotic mimics and exploring that possibility space. When can abiotic processes produce phenomena that look like phenomena that could be produced by life? We need that data point, especially if we want to try and use Bayes' theorem to quantify uncertainties. And finally, astrobiologists making biosignature judgments often need to factor in considerations that are best described as historical, philosophical, or sociological. And this adds to calls for greater support for meaningful interdisciplinary engagement in the field. We say this partly because it is in light of these historical examples that that some of these worries about unconceived alternative abiotic explanations really get their teeth. There are several examples in the history of astrobiology of something being put forward as a biosignature, and then eventually an abiotic explanation was invented. But not only that, after the abiotic explanation was invented, it was widely seen to be the better explanation, and the idea that we had a biosignature was no longer valid. Another example that we put forward to illustrate this is the meteorite, the Martian meteorite ALH 84001. Another example of there being, in fact, we found out quite recently, a good abiotic explanation of the phenomenon. So we need these historical stories to help us have on our radar the importance of thinking about unconceived alternatives. Okay, so I think I'll leave it there from now. Hopefully that's given you plenty of food for thought. I think it's given you a decent overview of what this paper is doing. This is our author team. And as I said before, this is part of our Eureka project, which is based at the University of Durham in the UK. Okay, thanks.
Thank you, Peter. So I see there's a lot of discussion going on in the chat, but if people have questions, please raise your hand, and then we can start the discussion. Okay, Daniel, Sean, Clemo, Catherine, wow, okay. So let's start with Daniel.
Yes, many questions actually. Very, very cool talk. So I really enjoyed this, and also thanks, Ravi, for always bringing these amazing talks in this series. So my first question would be, did you take in account that this uncertainty also scales with the scale of our detection. So let's say if we find an isotopic fractionation in an in situ probe, there might probably be more unknown potential explanation than something that changes the planet on a global scale.
Yeah. Again, I think every example is going to have its own nuances. It's hard to sort of generalize across cases. And I mean, there have been cases put to us where people have said, look, if we found this, then very quickly everyone would say it's definitely life. We wouldn't have to go through some big sort of scrutiny taking years. And I mean, there are scenarios like that. The uncertainties are different in every case, I think. So I think the best you can do is let the community decide, and that's why we think this IPCC option is flexible across different kinds of cases. If it's judged by the community that this possibility space is thoroughly explored, then that's the best we can have. So yeah, I don't know if that helps, but yeah, we certainly want that. We just take that as an advantage of this approach, that it's flexible across very different kinds of cases and doesn't sort of generalize too much.
Daniel, let's go to Sean and we'll come back to you for more questions.
Yeah, thanks both, Peter. That's great talk. Thanks for hosting it, Ravi. I want to start just by saying I think there's a lot of shared goals here, because I think that the communities that led to the reports you mentioned, or the frameworks you mentioned, the cold scale and the framework for biosignature assessment, also acknowledge the need to consider previously unconceived mechanisms for producing a potential biosignature. And both of those scales have explicit steps in their frameworks that account for that. The cold scale, for example, it's anticipated that, well, I think with either group, it's anticipated that no matter how much research we do in advance as an astrobiology community, when we make an announcement to the world that we think we found something that could be a sign of life, that the amount of attention from our colleagues, both in our disciplines and in disciplines that had not previously been engaged in the standards that we're setting, will increase dramatically. And from that, we're anticipating, again, no matter how much pre-work we do on false positives, we're anticipating new ideas for how those signatures could be created with previously unconsidered means. And that's why in step 6 and 7 in the cold scale and in certain steps of the community assessment, there's an explicit space made for follow-up investigations with alternative approaches or complementary biosignatures to test those competing explanations for the data set. I mean, this is kind of how the scientific method works. There's an anticipation that debate is going to happen. And what I find, and I will say, I really do love. I don't think there's a disconnect or a tension there. I think everyone wants that to be part of the process. What I find interesting is I was one of the folks inside on some of these things advocating for using the IPCC report. And one of the reasons that wasn't a direction, at least for the cold scale that we went down, was exactly this issue that you brought up at the top of the talk, which is if we were to go down that path and say, okay, we want to put some confidence scale to this. The way the IPCC has done that is they've brought together intermodal comparisons of things like, climate models for Earth, where you are flipping a switch to turn on and off the anthropogenic emissions and turning on or off the natural forcings to the climate. And you're trying to use that suite of models to then ascertain the certainty on the degree to which climate change is anthropogenic or not, or how much is happening, or whatever the statement is. If we did that for biosignatures, we'd be implicitly basing our assessments on models that are inherently Earth-based. And I think the perception of the astrobiology community is if we did that, we would not be leaving enough space, because those models are so rooted in Earth. We would be essentially overstating our confidence if we went to a confidence scale like the IPCC has done. So I think there's a shared goal here. I'm not sure there's agreement on the best way to get there. I will say this though, I think one model would be to add confidence levels to any of the steps in a framework, right? So if you took the community framework or the cold scale, and on any level you say, what's the confidence that this thing has been achieved? Then you can have those confidence statements along each line and still leave space for the work that has yet to be done. So yeah, overall, I think there's a lot of alignment in what people are trying to do, just maybe some differences on what works and in what situation. I'll also say that I think that some of these things may work better for exoplanets than in situ, or vice versa. And one of the things that this community has been trying to do is create something that works across all the different venues that planned searches for life will occur, and not have it just be on, for example, the oxygen methane pair.
Yeah, thanks. Yeah, loads of good points there. I mean, I think we were certainly pressed in the revise and resubmit to consider these synergies between what we're trying to do and what these other papers are trying to do. And we say in the paper that we feel like there's no reason, for example, why there couldn't be this IPCC approach to reflecting the certainty continuum, but also the Nexus N-fold framework could still be there as sort of an illustration of best practice scientific methodology. I know that there was a suggestion with that. So even though that's a long white paper, there isn't actually a proposal, a concrete proposal in there for uncertainty judgment. So it always felt to us like they'd gone more towards representing sort of the iterative methodology that's there. But you could add to that, like you say, the more you've done this and the more you've answered these questions, then gradually your confidence goes up. So you could combine that maybe with some kind of scale.
Yeah, and sorry, the question I would have is, how would you propose we get there? That's the question. Like, how do we get to a certainty scale? Because I think the way that one would do it would likely go down one of two paths, right? If we took the way that they do it for the IPCC, it would be spinning up a bunch of models for any. It's not just the models, but one of the core things that we would want to do is spin up models for creating the biosignature with or without the potential biosignature with and without biology involved, and doing a massive interval comparison. Is that the pathway to doing that, or would it be something like you just suggested, which is as we check off certain boxes, our confidence increases at some
The ideal scenario for us is that, I mean, this is idealized, but a phenomenon is put forward or discovered, and the community says we're not going to judge our confidence until the international community has had several years to scrutinize this, and after that period there will be a committee put in place to assess that scrutiny and ask questions like, what now is the extent of the evidence that this is biotic, and what is the degree of consensus in the community? And then they would put together a report, and then they would use the IPCC framework to tell us whether we should have high confidence, medium high confidence, or whatever. So, I mean, it may be unrealistic to sort of ask for those several years of scrutiny to take place, but that's the ideal for us. I mean, in the cases are so different, as you know. I mean, if you take the case of the Martian meteorite, that's sort of a debate taking place over decades, and you would have come up with different judgments at different times, but we still feel like it can the framework can be applied to that as well as it can to an exoplanet atmosphere biosignature. You just let the community sort of do its thing, and then you'd have to put together a committee that would be in charge of trying to assess based on the literature they've seen over a period of years, what's the extent of the evidence, but also what's the extent of the agreement. Again, like a big part of our case is just the amount of scrutiny this uncertainty framework has had over the last 20-something years in the IPCC case. So we kind of feel like we don't need to defend it as a useful tool. I mean, it's been debated to death, and I think it's seen as useful despite possible. Of course, there are criticisms. I think there's going to be criticisms or possible criticisms of any framework, but this is one that's really stood the test of time. Of course, you could argue that it should be thrown out. The only reason we keep it is sort of inertia, because we want to like compare uncertainty now with what was in the last report and what was in the report before that. So we're kind of stuck with it now. I mean, that's one possibility, that it's really is quite flawed, but we keep it around for the purposes of comparison. But we don't really feel that. We feel like it's withstood the criticisms pretty well.
Okay.
Yeah. Okay.
So sorry, I didn't mean to interrupt. I thought you were done, and so I was just saying, okay.
Well, I mean, yeah, Sean made a lot of points, but yeah, I guess that's the key thing I wanted to say. Thanks, Sean.
Okay. Yeah. Clemo, go ahead.
Yeah, thanks very much for these very interesting discussions. I have a few remarks on the main concept on some of the main concepts you discussed. First, the possibility, so three things. So first, the possibility space. So this discussion reminded me of Carl Sagan saying that the extraterrestrial intelligence explanation is an explanation of last resort when everything else fails. But when you say when everything else fails, it assumes that you have explored the whole possibility space, which I think is completely, utterly impossible to explore all other possible alternatives, because you can build an infinity of scientific models that would be more or less good. The second thing about abiotic mimics, I think it's a very interesting point, very important. And the way I see it cognitively, it's a way to fight against the confirmation bias. So to look just for the things that confirm our theory. And yes, lastly, and then I will end with a question about the IPCC framework. Yeah, I like it very much. I think it makes a lot of sense because it combines two dimensions. One is social and one is objective and scientific. So the social thing is the agreement part. But indeed, also the problem with the social dimension is that in the extreme, you could have situations where a whole big group of scientists are wrong. They could. And I mean, science is not a democracy. It's not because a lot of people believe that something is true, that it's true. So that's a concern I have. And also, yeah, I wanted to ask you in the IPCC if the agreement part is formalized with expert survey. So we could say, I don't know, 200 scientists out of 250 agree on this, and therefore we can have a high agreement.
Yeah, thanks so much. Yeah, great points and great questions. Yeah, I agree basically with everything you said, including the worry about the social dimension. I still think that often it's the best we can have. There are cautionary tales from the history of science of the majority being wrong about something, but it still seems in many cases it's the best we can do, and we just have to be fallibilists and say the majority of the experts think are very confident that we've discovered life, and that is a good sign that we have discovered life. But yes, of course, the majority aren't always right. So yeah, it may just be the best that we can do. I think there are interesting cases in history where, you know, there's sort of been quite a strong consensus. You know, maybe you can, one of my favorite example is continental drift, and the quite strong statements that were made that drift was impossible, and over quite a long period of time. But, you know, in that case, there were sub-communities that were, that had just enough freedom to carry on making the opposite case. But there's what came out of that was that at the GSA conference, the Geological Society of America conference each year in the States, they have a session which is devoted to unconventional ideas and outrageous hypotheses. It's a session that the community has decided they want to have at their conference in order to allow people with unconventional or heterodox ideas to have a platform, because they recognize that in the case of the continental drift debate, that didn't happen enough. There really was suppression of what turned out to be the right idea. So my own view is that I actually have quite a lot of confidence in the social dimension, whilst allowing that there are these important cautionary tales.
All right. So Catherine, please go ahead. Thank you for being patient.
Not at all. No patience required. This discussion is fascinating. And thank you so much, Peter, for the paper. And thanks, Ravi, for organizing. I expect all my questions will be answered as soon as I read your paper, but until I get my hands on it, I'm going to interrogate you. So I'm just wondering, did you also consider other models from the world, for example, of evidence-based medicine, for example, the Cochrane reviews, or did you just kind of zone straight in on IPCC?
Yeah, we didn't look at evidence-based medicine. So, okay, you know, it could be that we've missed something there, or at least we should have compared what we were doing with that case.
Okay. So you went straight to IPCC, and then I'm wondering, similarly, if we kind of approach it from the other end, from the end of public reception and understanding of the results and ambiguity, et cetera. So from the science communication research standpoint, did you actually look at the studies of IPCC communications effectiveness? Like, has it worked adequately?
Yeah, well, we did. I mean, we had a look at the literature, and there's some you'll find referenced in the paper.
Great.
We don't have a thorough discussion of that, but we mostly reference, you know, the people that have, where we felt like it had withstood the criticisms. One criticism being that it isn't a very effective way of communicating the state of play. Yeah, I think what we felt on balance was that it was, but yeah, you've got to make these trade-offs with anything like this. And one thing that I think is good about it is that, you know, ultimately you can boil it down to, look, here's a statement and we're this confident about it. And as long as someone, you know, understands the statement, then they can understand how confident scientists are about it. Mm-hmm. So, I mean, it's simple information. Of course, the IPCC sort of, you know, it has this sort of graded approach where you've got the full report, and then you've got these summary for policymakers. You know, so there's sort of the, you know, you can go as deep into it as you want.
Yep.
And maybe you know, I also think that's a good approach, and that could be adopted potentially by in other areas.
Layering, yeah. I guess I'm struck by first of all, a little bit of skepticism about the effectiveness of the strategy, given how long it has taken some policymakers to get on board with the reality of climate change. I think we get to ask that question. I think the other thing that just springs to mind for me is how much a lot of people really, really, really want it to be life. And a lot of people really, really want it to not be climate change. And so that's an interesting kind of disanalogy between the two situations that might be worth some exploring. But anyway, really looking forward to your paper. Thanks so much.
That's a great disanalogy. Yeah, thanks. I mean, we've been seeing the analogies, I think, more than the disanalogies, maybe because we're putting it forward so strongly. But yes, I mean, it's it'd be really interesting to investigate that disanalogy more. I think that's an important thing to investigate. I think, again, this is never going to be perfect, and but you know, I think scientists, like everyone else, can get too excited about an idea too quickly. You know, there are knee-jerk reactions sometimes. There's confirmation that you're biased. I mean, there's biases in all of us, and my own view is that although there's that disanalogy, it would still be the case that, you know, this framework can work pretty well for climate change, and pretty well for astrobiology, and it's you know, you're not trying to put a number on these things, you're just trying to put something in quite a broad box.
Yeah. Great, thank you.
Thank you.
Yeah, thank you, Catherine. Excellent. So Vincent, again, thank you for your patience.
My apologies. Do we still have time for a question? I see it's already 1 o'clock.
If the speaker has the time to answer, then yeah, sure.
Well, so one quick one is regarding like the size of the research communities. I have the idea that the IPCC, especially the example you're referring to the oceans, that's a much larger community, right? Whereas in our community, I would say we definitely have some occasions where there is a single team or a single person like being sort of the proponent of a non-classical explanation, I would say. And sort of in line with that, like thinking back about the Oumuamua case, we now, I think, classically sort of define this as being it's either non-classical, let's say life, or it's something natural. And do we leave space for just we don't know it? Because it kind of, people seem to be taking advantage of the fact that, oh, we're not sure what it is, so it must be this. But I feel like there's a whole lot of space between we're sure it's this, or this is an explanation, or that is an explanation, versus 80% we don't know what we're talking about in some cases.
In some cases, I think the framework would go like this. So a phenomenon comes along and somebody's quick to say this could be life. And you can look at the evidence and come up with a judgment for the evidence, but the framework wouldn't actually give you a result for agreement, because you'd have to say, look, until there's been a period of community scrutiny that, you know, crosses some threshold for being significant, we can't actually put a responsible value on agreement. I mean, there isn't much to say about agreement yet. So you, in that case, you would say, you know, it's too early to say, you know, which I think is totally responsible. You know, sometimes you're just going to have to say, don't ask us for a value for how certain we are yet. You know, this is just, you know, the dust is in the air. We say this in the paper about one of the cases. I think it's the Nutman or Allwood dispute, where I think we say in that case that initially there was just one paper and one team, and at that point, you know, the confidence result according to this framework will be undefined. But after there was a period of scrutiny, actually within 2 years, somebody put forward an abiotic explanation. You know, the agreement would never have got very, you know, as soon as it was defined, it would have been very low.
Okay, thanks.
Yeah, you had another point at the beginning, didn't you, about the size of the team? Oh no, it's sub-connected, isn't it? I guess.
Yeah, they would be correct, connected. Yes. Yeah. Okay. Thank you.
There is a ton of discussion in the chat, but I can stay here longer, but it entirely depends on the speaker and the audience availability. So
I just have five more minutes, I think, and
yes.
then I'm going to have to get off. Yeah.
Right. I totally understand. That's good. So, but if the chat is going to continue, this is being recorded, and if anyone has any more questions in the last 2-3 minutes, maybe you can go ahead and ask. Yes, Vincent, do you have still a question or no? Okay, Daniel, please go ahead.
Yeah, hopefully
Yeah, go ahead.
Yeah. Hopefully a quick one. So is it in principle the same for anti-biosignatures, or is there something per se different of, you know, being sure about something is an anti-biosignature or not?
I haven't thought about this much. My instinct is that is yes.
Because maybe I quickly explain where I'm coming from, and that gives you a moment to think about it. So I'm currently working on calculating the significance of the null result of, let's say we do a survey with the next generation of telescopes. We look at 20 exoplanets. We don't find global life on any of them. Then I'm exactly modeling these confidence. Let's say we are 95% sure that we didn't find life in any of them. What is the upper limit we can put on, you know, the frequency of life or something like that? And therefore, there it becomes even more important, the credibility of the confidence in the anti-biosignature than the biosignature itself. And I'm just curious, is it easier? Is it harder? Is there less space that we didn't explore, or more because we don't even know what life is?
I think in some of these cases, there's going to have to be, frustratingly, there's going to have to be quite a long period of community discussion before we can use this framework and it be really helpful. You know, if the evidence that we have is limited, then you're going to be less confident about where you're putting a point on the x-axis. And if the community, until the community's had sometimes years of discussion, you're going to be uncertain, how much agreement is there. Sometimes it's going to be really hard to put any figure on that. So I think there are limits to how useful this framework can be when the evidence is really thin and the community is only, look at the ALH 84001 debate. It's a decades-long debate, but unfortunately, my own view is that many debates in astrobiology are going to be like that, where there's a lot of uncertainty about where we are and until many years have passed. But yeah, specifically about anti-biosignatures, I'd have to think more about that in light of some examples. But yeah, the case you mentioned sounds really interesting. I'm not sure.
We still have 20 years before these telescopes are flying, so we have time to agree on it.
Good. Thanks.
So a couple of things before we go. There are really good links that Catherine posted in the chat. Because this talk is recorded, once we post it on the webpage, you can go ahead and see the links. Or we have a Slack channel for which we started 3 years ago on TechnoClimbs. If you want to be added to the Slack channel, please let me know, and we can continue the discussion over there if you want. Just send me an email if you want to be added to the Slack thing. I guess, Peter, you're out of time now. Yes. Okay.
Yeah.
Great.
Yeah. Better go. I've just saved the chat, so I'll have a look through the chat afterwards. But yeah.
Yes. Yes. I'll post the link on the webpage as soon as I get the recording link. But again, thank you so much for agreeing to give this talk, and thank you everyone for participating. I know if we had more time, we would have had more discussions here. But again, if you want to be added to the Slack, let me know. We can continue a discussion over there. All right. Thanks again. We'll see you all soon. Thanks, Peter.
Thank you. Thank you, everybody.
Bye.
Bye.